Hi all, this is Shubham and I'll be demonstrating MongoDB sharding on AWS. Sharding basically is splitting your data into smaller chunks and spreading it across separate nodes. As you can see here, I have created two data shards across which data is distributed, and I have a config server here which stores the metadata for sharded clusters. I have a replica of each of these instances in case one of them goes down. So let us jump into the instances. Before that, so this is my Mongo's cluster. Okay, so the config file of Mongo's in config file of Mongo's I have set up the port as 207017, and in sharding I have entered the name of this shard, the name of this replica set of our config server and its private IPs. For config servers, for config servers, the port is 27019. Bind IP 000. This is the replica set name which we saw here, and the config server is our cluster role. So this acts as a config server. Same as this is a replica, the config file will be same. Okay, so let's try this. These four are our shards. This is shard 1 and its replica, shard 2 and its replica. This is config server and its replica. So let me open the config file of shard1. So shard1 has replica set name as shard1 and its cluster role as shard server. Similarly, shard2 should also have the same thing. Yes, shard server and replica set name is shard2. Now I'll connect to this and do rs.status. As you can see, its replica set is up and running. Its health share says as 1. Then for rs shard2, I'll do so this instance and its replica are up. So now let us add some data in our Mongo's cluster. But before that, let me set up my key. So what I am doing here is this command will already be run in admin db. So what I am doing by this command is I'll be setting database 281 and collection BIOS, and this is the name of the collection, and this will be the key which will be sharded, on which sharding will be done, and this is hashed. So Mongo partitions data in collection using ranges of shard key values. Ideally, shard key should be decided in such a way that it allows MongoDB to distribute documents evenly. So there are two kinds of sharding: hash-based sharding and range-based sharding. Hash-based sharding takes your key, computes the hash value, and uses it as hash key. Range-based collection is divided into ranges. So if my key is age, then ranges will be 0 to 20 here and 20 to 40 here. But here I'll be using hash-based sharding, since range-based sharding may cause problems if majority of the data lies within one particular range. That will be overutilized, and data and load distribution won't be even across the shards. So hash sharding will give us even data distribution compared to range-based sharding. So as you see by this command, By this command, I'll set up my key as my first name. Now I'll insert some data. This is the BIOS collection data in my 281 DB. Data has been inserted. Okay, so I have 70 data records. Let us try to read from them. Okay, I'm on the wrong DB. So 39 records are here. Now on shard 2, shard 1 had 39. What about shard 2 should have the remaining ones. Yes, the 31. So data is approximately 50% distributed across shard 1 and shard 2. So for my wow factor, I'll be using VPC peering connection. So VPC peering connection is a network connection between two VPCs. So it enables you to route traffic between these VPCs. Instances in either of these VPCs can communicate with each other as if they were within the same network. So you can also create VPC peering between your own VPCs or with a VPC in other AWS account. It can also be in different regions, which is what I have implemented. This is called inter-region VPC peering connection. So here is my React 1 instance. This is present in my VPC called, which is my VPC is so 281 personal project is the VPC on which my React instance is present, and this VPC is used in my peering connection. See, it is C and this, yeah. So this is the requester VPC, and the second VPC is the VPC is in my Oregon region. This one, DD9E1, and I have also set up a React instance here. So this is the region, this is the instance which is in the Oregon region, and we'll be communicating between these two instances. So these instances are already part of a React cluster now. So this is the 1.93 is the private IP of this instance, which is part of the peering connection. So how peering connection connects is using a route table. So route table has routes. So these are the routes. This is the CIDR block of my VPC in Northern Virginia. This is the CIDR block of this second VPC. If I remove this CIDR block, my VPC won't be able to communicate with other VPC. So you can use this route table to decide how you want the communication between our VPCs to happen. So now since both the CIDR blocks are there, we should be able to communicate between these regions. So first instance .1.93 I already showed you. Now 1.68 is in Oregon region. This is the React 4. Now I'll add some data here. Let's add some data here. The fooboard bar has been set. Now I'll try to read this. It gives us foo bar. Now let us update the data and see if the updated data is accessible. Now I'll change the value to dog. Value should be visible. So if the value has been updated, the communication between these VPCs over different regions is happening. So lastly, the cool thing about VPC peering here is that it uses existing AWS infrastructure and it does not rely on internet for access between these two regions. This gives us best throughput and security. Thank you.